Hello, everybody. I got a question this week about this specific question or problem, I guess, from the homework. And I thought I'd go ahead and make a video going over exactly how we can solve it. So the question is, it's asking us to differentiate the following function, which is f of x equals ax plus b all over cx plus d. Now, this probably looks pretty scary to start with. It's much more complicated than just a more straightforward differentiation that we've been doing so far. But the way we can solve a problem like this is by using the quotient rule. Now, this is essentially what the quotient rule states. It says that if you have a function f of x that is composed of two smaller functions, little f of x and little g of x, the primed version, the derivative of that function, as we see here, big F prime of x, is broken up into all of these subcomponents. So the derivative of the top part times the non-derived version of the bottom minus the derivative of the bottom times the non-derived version of the top, all divided by the bottom squared. If it's easier for you to think of it in terms of top and bottom, like I described it, it's written out here as well. I'll try to put a link to the page where I found this little rule if printing it out would help you in the description of this video. But before any of that, let's get started on actually solving this example. So the way I want to start out by doing this is I want to determine what our little f of x and our little g of x are, so that we can use them later. So we can plug them into the formula for the quotient rule. So I'm going to go ahead and do that right now. So we're going to want to find our little f of x and our little g of x. All right, so our little f of x is just going to be what's in the numerator, which is ax plus b, and a and b in this case are just random constants. And our g of x will be what's in our denominator, which is cx plus d. All right, so now that we have those written down, we're going to want to go ahead and find our little f prime of x and our little g prime of x. So let's go ahead and start with our little f. So we rewrite that as follows: f prime of x equals, and now we're just going to go ahead and differentiate it. So just to make sure we're all on the same page, remember that when you see an x like this, it does have a 1 in the exponent. We just, by convention, don't write that there. So for the sake of this, it's important to remember that. So when you're differentiating something, what you're going to want to do is you're going to want to take whatever is in the exponent here and bring it out front. So this would then become a times 1. Because we're taking this one and we're putting it out front like that. And then what we do to the exponent is we subtract 1 from it. And that's how we do this sort of differentiation. And finally, for this last term, the b right here, when we're differentiating in regards to a certain variable, in this case, we're differentiating in regards to x. If we have a term that doesn't contain that variable, we just get rid of it. So that just becomes 0. So that b just becomes 0. So finally, when we rewrite it, what we're left with is we get rid of the 0, x to the 1 minus 1, that's x to the 0, so that just becomes 1. And this 1 also goes away, and we're just left with a. All right, so we're going to go ahead and we're going to do the same thing for our g. It's almost the exact same function, just with, it is the exact same function, just with different constants. But I'm going to go ahead and do the steps again. Remember, we take the 1, we bring it out front. So we have c times 1 times x to the 1, and then remember we subtract 1, so 1 minus 1, plus the d, again it becomes 0 because it doesn't have the variable we're differentiating, so plus 0. And again, the 0 goes away, the x to the 1 minus 1 goes away, and the 1 goes away, and we're finally just left with c. So now that we have our f of x, our g of x, our f prime of x, and our g prime of x, we can go ahead and plug it into this formula right here. So I'm going to set that right here just so we can keep that in mind. So our big F prime of x now equals f prime of x, which we know from right here is just a, times our g of x, which is right here, cx plus d, minus g prime of x, so minus our g prime of x is c, times f of x, which we have right here is ax plus b. Finally, this is all over g of x squared. So we have that right here, cx plus d squared. So technically this is our solution, but obviously we're going to want to simplify things a bit just to be good math students. I'm actually going to leave the denominator as it is because that's a simpler way to write it, and I think when we're simplifying we want to keep it as simple as possible. But for the numerator, I'm going to go ahead and distribute this a and distribute this c. So let's go ahead and do that right here. Big F prime of x equals, we're going to distribute the a, so that becomes a cx plus d. And we're going to distribute this negative c. It might be easier to think of this as a negative c because the negative is getting distributed as well. So this becomes negative a cx minus cb. And this is all over still cx plus d squared. Now you're going to notice that in the numerator we have a term that cancels out. This negative acx cancels out with the positive acx. So that finally we're left with the final answer of f prime of x equals, oh, whoops, I just noticed a mistake up here. I forgot to distribute this a to the d, I just wrote d, so this should be ad. I apologize for that. So, I'm sorry, our final answer will be ad minus cb all over cx plus d squared. So that is a sort of introduction to the quotient rule that we use for differentiation. Please let me know if you guys have any additional questions. And yeah, thank you for watching.